The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to another Nautel webinar. This broadcast is originating from our Hackett's Cove office in Nova Scotia, Canada, where it is a beautiful, sunny plus 6 degrees. Very nice for December 1st day in Canada. I guess I say good morning, good afternoon, and good evening because I see from our list I have people from all over the world attending, so this is very nice. My name is Wendell Lonergan, and I will be talking about N+1 architectures for FM transmission site applications. Today's agenda, I'll start off with an introduction, a little bit about myself and the company, why somebody would use an N+1 system. Then I will talk about some of the details about specific N+1 applications that we've done. We'll open the floor up to some questions. You can type some questions into the webinar screen. And I'll give you a slide that will show you where you can get some more information about Nautel. I've been with the company for 30+ years. I spent 23 years in engineering. I started actually working in research with the founder of the company, who's the gentleman kneeling to the far left of the picture you see on the screen. That's Dennis Koval. He, John Pinks, and Dave Brace are principals of the company. And we are now 42 years old. And just gone through a fairly major design renovation with our broadcast transmitters, and from the early days you see 3 engineering staff there to what we have now is a fairly large engineering team. This is in fact just our FM team that you're looking at, who completely redesigned our NVSeries transmitters and NVS transmitters. In total, we have about 165 people here at our Nautel Canada facility, 40 or so in Bangor, Maine, and we have staff of about 5 in Quincy, Illinois to help service the central time zones of the U.S. On the screen you see a map of the globe to the right with many dots. These all represent transmitters that we've delivered over our 40 years in the business. So you see we're a well-established company, and populating the world with their transmitters. This slide shows the product families that we have. Our medium wave transmitters on top, spanning from in the NX series 25 kilowatts to 800 kilowatts. Below the NX series, we also have transmitters that go up to 1 kilowatt. And FM, the bottom row, we see VS series addressing the low power market, 300 watts to 2.5 kilowatts, and the NV series, which go up to a phenomenal 88 kilowatts. Both the NX and NV series use the advanced user interface, which is the 17-inch color touch screen that's on the front of the transmitters that give you full diagnostics and test equipment built in. So why N+1? Why would you do this? Well, the advantages of N+1 are that it gives you a very cost-effective way of backing up main transmitters. Instead of having several services at a site with the main standby configuration, you can all rely on one main service transmitter and have a frequency, power, agile backup transmitter that automatically comes in and goes to the position of a failed service. So because of that, it's of course very cost effective. The transfer happens automatically with our own controller. Full power maintenance, so while your backup transmitter, your N+1 transmitter is in fact on the air, you can do full service maintenance of your down transmitter. So you have fantastic service, and you know that when you go back on the air, you'll be operating at full power again. And it's very floor and rack space efficient. So what we mean by that is, you have less transmitters on your in your studio, and this is of course very important if you're in a site where every square inch is costing you money, like in the Tower of the Americas, the Empire State Building, where space is very, very at a premium. And even past that, NVS transmitters we're offering now with Orban inside to save you even more rack space. So this is a way of saving money for you. The backup transmitter sits completely static when it's not in use. So if you have lighting issues with the antenna, it will not affect your backup transmitter. All the programming is automatically transferred to the N+1 transmitter. So you can have 6 different services, but because the services are, of course, all different with different processing, this gets automatically transferred to the N+1 transmitter with the correct program feed and frequency and power level you need to operate at. The whole system can be locally controlled or remote controlled by a web interface. And for multiple systems, you can actually select which station has a higher priority. So if you'll imagine a 5+1 system where there are 5 main service feeds going into the air, and position 1, for instance, may fail, but it's not the highest priority, and another position, for example, position 3 does fail, and it is a higher priority. After initially selecting the position 1 transmitter, when position 3 fails, the system will automatically put in the N+1 for service number 3 because it is a higher priority. So this is all selectable by the end user. So basics. The system is obviously made up of service transmitters, a +1 transmitter, and a system controller. The system controller, the SC1 that we have, will handle up to 6 identical active transmitters, but above that, the controller can actually be cascaded, so you can increase the number of N up to as many as 12 if you wish. You can even program the system for N+2. In other words, you can have a second backup transmitter if you wish. We've actually got one of these systems designed and in place. Backup transmitters are sitting static when they're not in use, so the reliability, of course, is going to be very high. The fans are not running, so all moving parts are off. The audio switching can be done in a number of different ways. These systems tend to be customized, so you would, talk with one of the salespeople at Nautel, and we would customize the system for your specific application, whether it's you're using a composite feed or an AES, left plus right, however you're feeding your program into the transmitter. And of course, everything is, once it's set up and it's put in the auto mode, everything runs by itself. Here's a simple schematic of a 2+1 system. So in this situation, you have, I've shown an older model, a vintage model, if you will. Transmitter is a V10, so it's the system before the NV, and you see at the bottom left the SC1 controller. So the way the system works, the 2 top transmitters are the main service transmitters. They will be providing service through the combiner to the antenna, and their signals are monitored. The output of these transmitters are monitored by the controller. If the signal goes bad or goes below a preset threshold, which is the gain user defined, the SC1 will cause the program switch to select the program for the failed transmitter, feed that into the +1 transmitter, set the transmitter to the proper frequency power level, mute the failed transmitter completely, turn the RF switch so that the +1 transmitter is now applied to the combiner, and the transmitter that has been inhibited and put off air, that will be routed into the test load so that you can go in, override the interlock, and do full power testing with it. This is a system drawing that we did for one of our first, this would be a 4+1 system, 10 kilowatt NV10s. This particular system is the switch matrix mounted on top of the transmitters, and of course could be mounted behind wherever you wish to do it. Dummy load to the side. The Pi rack, in this case, there was no Pi equipment in it. It was just a simple SC1 controller and the switch. Typically, this equipment rack is filled with audio test gear and whatever your specific application requires it to be. When we look at the SC1 controller itself, it's a simple 19-inch rack mount unit, fully software controlled. It listens to the transmitters via web interface, and it can be controlled by web interface as well. So it manages the switching of both the RF and the audio systems. It monitors the transmitters. You can actually read the forward power status on its screen of all the transmitters if you wish. So from a remote control point of view, if you wish, you can just look at this unit, and if it shows a fault, then you can drill down and go into the AUI of the failed transmitter if you wish. It's just a blow-up picture of the SC1. It has a small digital screen, as you can see in the front, which gives the status of the individual transmitters, gives the status of the RF switches, whether you're in automatic mode or manual mode. Tells you which transmitters are into the dummy load. Full status from this point, and what thresholds you can set up for your transfer. It's all done on this screen. So I'm just going to show you a few slides right now of systems that we've done as we go through the power levels. So this is a system that we did for a customer. These are VS1s, 1 kilowatt systems. The actual switch matrix isn't shown here, but these transmitters are all switched with 7/8 CIA RF switches. On the left-hand side, you see program input equipment that was specified by the customer with patch panels, monitoring receivers, a large audio amplifier and speakers, and of course the program switching equipment. This also has a forward power meter at the top. The same customer actually ordered VS 2.5 systems as well. So we see the same program input equipment rack, but we now have the bigger transmitter, the VS 2.5, and this is now, again, a 5+1 configuration. The SC1 controller is mounted on the top of the transmitter rack. So this is an actual picture of an NV5 5+1 system that we shipped. This is the customer's installation that they have done. In this particular case, as you can see, it's a smaller RF switch than we saw earlier for the NV10 system. And you can see all the transmitters are operating with their AUIs turned on. This is a picture of the NV10 system that was shipped. This was actually shipped 2 years ago, and we see the larger, these are 308 switches on this system. Commissioning celebration. This is a recent shipment we did of NV5 5+1 systems. You see the cake, everybody's happy looking at the AUI and the transmitters. In the background, you can actually see that the RF switches are mounted a considerable distance from the transmitters. They're actually mounted on top of the combiners in this particular application. So as you can see, you know, we customize the system depending on your needs, and your building's particular layout, which is, of course, very important in power situations. Additional considerations. Of course, each of the main program service transmitters are a single channel operation. The audio coming from it and the RDS, this is all switched depending on your specific needs. So we will design the switching depending whether as I mentioned earlier, whether the audio is the composite or AES or what have you. For automatic switching systems, of course, there are always a motorized switch matrix. We have done manual systems as well, where people choose to have a patch panel in place of the switch matrix, but of course that is manual and not as convenient. The outputs switch to antenna or down below, of course. You can have separate antennas or a common antenna user channel combiner, and of course, as we mentioned, the common antenna circuit requires the channel combiner to put your signals together and combine them for the single antenna. Which brings us to another point, which I'll bring up 2 slides from now. So, of course, the transmitters have multiple levels of control, regardless of whether it's a VS series, the low power, or an NV series. From a remote control point of view, you can see everything on a remote keyboard or remote monitor that you can see in the front of the transmitter. So the 17-inch touchscreen screen of the NV is effectively available for every one of these systems. This touchscreen includes spectral analyzers, so you can see your broadcast, make sure you're compliant with everything. There's lots of monitoring and control functions. Everything in the transmitter, there's a huge amount of diagnostics with these transmitters. Custom metering can be pulled up depending on your own preferences. There's logins of all these functions. You can have the transmitter actually send you an email if there's a fault that you consider worthy to run to the transmitter site. Built-in instrumentation, modulation monitors there, audio and RF spectrum analysis. Now, combiner equalization, previously I said that if you're going to go into a common antenna, which is the more common way this is done, as I'm sure many of you know, combiners have frequency responses. So as an added benefit, we can measure the frequency response of these particular service combiners and put in an equalization in the program, which improves your left to right separation, your signal to noise. It improves the signal so that it's as if you've purchased a much wider bandwidth antenna and into it all by yourself. This is a slide that just shows some of our other services and sort of a more macro view, if you wish. We have dedicated project managers for some of our much larger projects. In fact, the project that you saw the photos of the VS series is actually, that's part of a project that has 180 transmitters involved. So that has a dedicated project manager for that. Third-party integration specialists. So we have many people that work with us around the world who help integrate these services, do installations for us of the transmitters, the antennas, combiners, the complete service. We, of course, have site survey service, which is, again, very important on very large transmitter installations. International financing. And with our team of 40 engineers, we have a great solution breadth. We have a good bullpen, if you will. So, learn more questions. How do you find more about us? If you go to www.nautel.com/N+1, you will actually see a couple of videos that I did of some of the systems that we're going through our test room. So if you want to, good way to get a sleep at night, you can watch one of those. In terms of this webinar, you can go into the little box which is questions, open that up, and type a question in. And if you have any questions, I will call up my little screen and answer them for you. We also send out a Nautel Waves newsletter. So if you wish to be part of that and you're not now, you can send us an email and we will make sure you're added to that list as well. So I'll watch the screen, see if there's any questions pop up. This is a picture of our sales group. So we have in Europe, South Africa, we have Hal Neller. Latin America, Caribbean, Gerardo Vargas. Asia Pacific is John Ebnauer. Hal also has a dual role with the market development. I handle the Middle East and Northern Africa. Steve Schmidt works with everybody from a system integration point of view. And taking the helm of the ship is Chuck Kelly, as Director of Sales. So I'll just open my local screen and see if there are any questions here. So far it's quiet. So I'll just give it a few seconds. Nobody enters any. I will say thank you for listening to me talk about this subject. If you come up with any questions afterwards, I'm at WLONERGAN@Nautel.com. Give me a shout. Thank you very much, and goodbye.